This slide presentation has to do with assessment methods that are used in doing TMDL analysis or RAPS type of analyses that you are learning about in BBE 4535 and 5535. I'm breaking this presentation into two parts, or at least I'm separating the assessment methods into two different categories, and I'll talk about what those are. So the objectives of assessment are to determine the characteristics of one or more pollutant loads. For instance, it could be that you're interested in looking at nitrate or phosphorus or sediment or mercury, and you want to be able to determine the characteristics of that particular load, the frequency at which it occurs, the magnitude of it, and that sort of thing. Want to then, from that, be able to determine how much reduction in the load is necessary to meet the particular water quality constraints. Those constraints might be a concentration, or they might be a constraint associated with the assimilation capacity of a receiving water, such as a lake. Here we want to identify then the categories of pollutant sources that, or even identify individual sources. So that would be part of the assessment procedure. So if you're looking at sediment, you'd want to know, is the sediment coming more from stream banks, bluffs, ravines, or from farmed, well, let's say from fields, or from the surface area of soils that might be because of construction sites or because of agricultural practices, or maybe forestry practices. It might even be sediment coming from military sites where there's practicing going on for by the military. We want to then be able to estimate how much pollutant load is coming from each of the sources, if that is all possible, so that you can then pinpoint those sources as a way of being able to determine where to make some changes for remediation of the pollutant load. And then once you do that, then we might be able to estimate how much change in water quality is going to occur as a result of implementing a BMP that would then reduce the pollutant load at a pinpoint location. And then the question is, well, what assessment method should you be using? And the recommendation is that we should try to keep it as simple as possible. Call that KISP. The method selected needs to be supported by the information available or the information that is attainable. The method selected needs to be conducive for the conditions or for potential interaction with the stakeholder community. And here's why it's very important that the information or the method that you use is supported by the information available, because you do not want to go before an audience of stakeholders and try to throw up a smoke screen over what you're doing. You want to be able to have information that supports your conclusions, because it becomes very embarrassing when you stand before a group and you can't really support the arguments that you're making. And then the method that's selected needs to be user-friendly, both to the analyst, but also to the stakeholders. Not that they would necessarily use the method themselves, but they want to be able to understand what you're doing. If you're using some model that's impossible for the stakeholder to understand, they're not going to be very accepting of the final results. So there are these two categories of methods, and this slide presentation, immediate slide presentation, is going to cover the first of the two categories. But first I'll define what the categories are. Category 1 methods are methods that are based on monitoring data or based on information you gain from the literature. So here the major interest is in the load of a particular constituent from a watershed. And generally these methods will not provide details of what's going on within the watershed. So it's a bit more difficult to directly pinpoint a pollution source. It does not mean that with these methods you wouldn't be able to use other logical approaches to be able to find out what a where in a watershed most of the load is coming from. And to be able to apply these methods, generally you're going to need to have detailed flow and pollutant concentration data. It's not the case when you're using just literature values to do the analysis. But if you're, most of the category methods that I'll be referring to here do require some flow and pollutant concentration data. The second category of methods are based on watershed scale modeling. And most of these models that are available will provide some detail of what is happening inside of the watershed, which of course will help you to try to pinpoint where the pollutants are coming from, what proportion is coming from a particular location within the watershed. And of course, there's lots of models that are available, and I'll be describing some of those in the next slide presentation or next video. And these methods range anywhere from simple spreadsheet models that require simple spreadsheet models to all the way up to models that really require significant computing power. And we'll be looking at some of those models during the semester. So let's look here at Category 1 methods. These methods, as I mentioned, do depend entirely on monitored flow and pollutant concentration records. In most instances, the flow sampling is continuous, but almost always the pollutant sampling is not continuous. And of course, now with the new types of sensors that are out there, like a YSI probe as an example, it is possible to continuously sample or to measure concentrations of certain pollutants like nitrate as an example. When flow and pollutant sampling are both continuous, the development load relations are fairly easy. But in general, most of the time we'll have flow data, but the pollutant sampling or concentration will be, you might call them grab samples. They're discontinuous, and that makes it a bit more complicated to come up with load estimates. When the flow is continuous and pollutant load sampling is periodic or event-based, statistical methods can be used to develop the load relations. Category 1 methods are useful to determine the current or historical loads that have occurred in a watershed. And the reason why they're used for doing current or historical loads, you need to have data. And so the data has to exist from either current conditions or from historical record. They are used to quantify loading from a watershed on a per area basis, for example, per acre, per hectare. We can then take that and we can, that information, we can compare loading from one watershed to other watersheds in the same area or region or in other regions. We can assess the impact then of the existing load on downstream receiving waters and beneficial uses. And we'll be looking at an example of these, or we'll be looking at this application during the semester when we'll use a method called the load duration curve approach to come up with what the load is. And then we'll be using a method called the bathtub method, which is used to evaluate the capacity of lakes and reservoirs to receive that load and still meet water quality standards. And this category of methods cannot be used directly to predict future loading change or land use changes on loading. To be able to predict those effects, you need to use Category 2 methods, that is, methods that are hydrologic models, water quality models that allow you to change the land use and come up with scenarios as to how the BMP might affect water quality. All right, so category 1 methods, they provide information on the aggregate load that's coming from upstream sources. These methods will not identify individual sources. The details for the watershed will be whatever scale you do, at whatever scale you do the monitoring. So if your watershed is 5 square kilometers in size, you'll measure the outflow and you'll measure some pollutant concentrations. You'll come up with a load. You would not know from that information directly where the pollutant is coming from, although you could use a line of reasoning that would indicate, or could be used to indicate, where that load is coming from. You could also make additional measurements that might help you to identify those sources a bit better or more clearly. And if you implement a BMP in a watershed, you should monitor at the scale that will show the impact. So as an example, if you have a 5 square kilometer watershed and you want to use, and you're looking at nitrate, and you want to see the effect of, say, a saturated buffer on the reduction in nitrate coming out of the watershed, well, then you should try to do monitoring at the scale at which the saturated buffer is implemented, and that would be at a scale much smaller than the actual size of that 5 square kilometer watershed, unless, of course, you apply the saturated buffer at a lot of sites throughout the watershed. So if you fully implement BMPs for the whole watershed, well, then whatever's coming out of that watershed will be, the monitoring at the scale of the watershed will be sufficient. But otherwise, usually we do not implement BMPs at every site within a watershed. We usually do it at locations where it's possible, economically possible, to implement it. And to really see the effect of that BMP, we need to monitor at the scale of the BMP practice. So there's some examples of these category 1 methods. One is the load duration curve. Second is the flux the flux model, which was developed U.S. Army Corps of Engineers. Method called Load Est, which is a load estimator developed by the U.S. Geological Survey. There's a method called the regression of pollutant load and flow, or the RPLF, which uses a minimum variance unbiased estimator technique, and then using literature values to estimate loads. So those are some of the category 1 methods. There are probably others, but among these, we'll be using the load duration curve, we'll be using the flux method in this course. We also will do something using the literature values to estimate loads, but that will be actually applied under category 2 methods.